Hi guys. In this lesson, let's go on to learn the networking operation in Ruff application development. Well, in our two previous parts, we talked about TCP and HTTP protocols, respectively. They are a transmission layer protocol and an application layer protocol. In this lesson, let's talk about the Mqtt protocol. The Mqtt protocol is also a communication protocol at the application layer. However, compared with the HTTP protocol, it is more convenient and concise. And it's also a mainstream communication protocol in IoT application. Its similarity with the HTTP protocol is that it also realizes encapsulation of TCP protocol. Different from what we talked about before, in the scenario of Mqtt protocol, its communication identity is quite different. As we see here, both communication parties use the Mqtt protocol or clients, and the server is only a message broker. It is responsible for forwarding messages. In terms of communication, if A wants to send a message to B, A is the publisher of the message, and B is the subscriber of the message. Under such a precondition, A can send messages to B. Let's look at this diagram. There are three roles in this diagram, namely server, client A, and client B. As we mentioned before, the server actually serves as a broker for forwarding messages, and both communication parties are clients. When A wants to send a message to B, A is actually the message publisher, and B is actually the message subscriber. That's to say, for A to B, it directly goes to the server, and the server sends it to B, thus completing such a one-way message pushing process. Well, if B wants to send a message to A, then B will be the message publisher, and A will be the message subscriber. For example, here, B pushes it. In this channel, it reaches the server first, and then the server forwards it to A, as we may also see here. Either A to B or B to A belong to the same topic, which is a vital term in Mqtt. That's topic. The Mqtt module is indeed an external module, not a built-in module, in the Node or Ruff SDK system itself. Instead, it is actually stored in the software repository. When in Node, it is in the npm software repository. When in Ruff, it is in Ruff Registry. Well, as to how to use it, we may refer to the NTM official website. First, open the browser and type in npmjs.org. Search Mqtt here. Enter. Here we can see Mqtt, its API, and how to install it. And it's worth mentioning that like the previous TCP or HTTP, the Mqtt is compatible with both Node and Ruff. As to its installation mode in Ruff, we may run a wrap install Mqtt. Such a command to install this Mqtt module, and the mode of reference is also the same as that before. Mqtt equals require Mqtt. The next diagram provides more details on how to use this Mqtt module. As we see, when we want to send a message from A to B, in fact, what both the two codes file A and B need to do is, I need to connect this server, originate a client operation to connect a server. Well, as we see here, this server is actually open publicly to developers. Both need to originate connection to this server. Upon originating connection, A is actually a message publisher, the topic of A to B, and it needs to call publish, then A to B, and then puts the message into the second parameter. Then B subscribes to such a topic, A to B, and then waits for the arrival of message. Let's have a look at the actual code. Look at A first. For client A, it should first require this Mqtt. After getting this Mqtt object, it originates connection to this server. Upon connection, it waits to confirm whether this connection is successful. If the connection is successful, it will, to such a topic of A to B, send a new message. In the new message, it says, I'm client A, and then ends itself. Now, let's look at client B. It's the same. It first connects this server and then judge whether the connection is successful. If the connection is successful, it will subscribe to such a topic of A to B, and then waits for the arrival of message. After the message arrives, it will enter this callback function. This callback function contains two parameters. One is topic, and the other is message. It prints the topic and the message. Upon printing, it ends this connection. Let's demonstrate it. Here, since B is the message receiver. So first, I open B, and then open A. Well, as we see, in fact, B receives the message from A, and the topic is A to B. The message is client A. Alright, so that's all for this lesson. So please look forward to our upcoming classes on Ruff. Thank you very much.
Ruff, make IoT easier.